My name is Tapana, and our group is Triple N. Next. So our problem is like usually sometimes we go to their public restroom and they have a bad smell or unpleasant smell like the odor or something. So and actually have sometimes we find it have the harmful gas like ammonia, which we cannot detect by our nose, and it have no smelling at all. It's like just the ammonia or methane they that usually fall in the restroom, and they have no automatic system at all to control fan or the UV light to kill those bacteria that have appear on the restroom. And they actually have no data tracking on air quality over time on those public restroom, uh, our home, or even our home ourselves. It have no tracking data on that. And the customer, our customer is actually be like the hospital that they have to clean every hour. So this can reduce this cost by using a UV light to kill the bacteria. And the factory is like they have to detect gas and maintain their hygiene in the environment. So this might help them to detect those gas that appear on the environment. And next is the hotel and resort that might choose this because to improve the guest experience and hygiene, sometimes they might dump the price of their room up. And the last one is their smart home that many people might concern about their hygiene. And this is the AC solution. Basically, it have the basic air freshener or deodorizer. Uh, it have no detection at all. It have no automatic, like, and they just replace that smell with fragrance only. They have no, or sometimes they might have a timer. And next is IoT toilet monitoring system. It usually just flush the water usage, like and they just didn't handle the smell or air quality or even the bacteria in the restroom. And next is the UVC disinfection lamp. It's like it's just a manual or timed UV light that it's dangerous to people that are present because they didn't detect the people in there. And last one is smart bedroom ventilation system. It only turn on fan based on the humidity or motion in the room. Uh, yeah.
Okay, well, let's talk about user case. Like you said in the title, Sting is closer than your expectation. So in many home and small department, bathroom and poorly ventilated after use the bath, smell can linger, moisture build up, lead to musty odor, and in some cases, poor airflow can increase bacteria growth. So after that, people may not realize those bad. And our system is installed permanently on the bathroom wall. It includes a gas, smell sensor, microcontroller, fan controller, and also UV light. And it was Wi-Fi module. And after the install, our device will help to reduce bacterial risk without harm intervention and also prevent mold and smell build up in humidity climate. And they also have alert notification from the web page. So those are the tech stack that we are using. So like we said that we will be create a IoT device to be the smell detector. So the first thing of we will use Arduino Uno to be the like the main device to be the creating, and it will be consist of IQ135 to be the input of those smell detection, and we also have BME uh 680 to be the humidity to be the gas sensor and also be able to detect humidity level and also temperature at that time. And we also have PIR motion sensor to detect the motion. And we also have relay module, LED, UV, and also fan. And they also have ESP32 in microcontroller. And let's talk about the software that we are using. Like I said, we will using Arduino, so we have to use Arduino IDE to push the program and also function those function into the our Arduino as a main board. And we also have to use Python for ML model and classification, and we will create the web based and have some functional about dashboard and using file-based and MQTT for data transmission. For the training part on a machine learning model to classify gas type from multi-sensor reading, we will use scikit-learning and TensorFlow Lite for embedded ML.
So next, talk about the system architecture. First step, we start by using multiple type of sensors to collect data about the presence and concentration of chemical gas in the air. Next step is once we have collected data, we train the machine learning model too. This model helps us classify the gas level as high or low, and more importantly, it can detect when the air becomes harmful to health. At step 3, we test the model using real gas sample to make sure it works accurately under the condition we expect in the real environment. So lastly, we send this data to web dashboard when where user can monitor air quality in the real time. If the system detects unsafe gas level, it will automatically turn on the fan and UV light to clean the air and send an alert to notify the user. So next is the summary. Our pain point is clear. Here people cannot detect all harmful gas by smell, especially those that are odorless and toxic. So our solution is to build an IoT-based smart system that can detect this gas and automatically act by turning on ventilation or alerting user. So we expect that we want our sensor can detect real-world invisible and odorless harmful gas using this sensor. And thank you.